Good evening, everyone. I'm excited to share our project titled Algorithmic Synthetic Data Generation Exploring Fidelity, Privacy, and Scalability. Let me quickly introduce our team. Daniel, Justin, and Thomas, we are a team with diverse backgrounds and expertise, combining science and banking. Before we dive into the problems, let me quickly explain what synthetic data is and why it is important. Synthetic data, as the name implies, is artificially generated data that mimics the properties of real data. It is important that the statistical properties of the original data, like distributions and correlations, are preserved to ensure practical utility. This artificial data facilitates model training where real data can be used due to privacy or scarcity. One of the examples would be the ever-growing need of new data to train large language models. The business problem we are presenting is a joint effort with Syntheticus. Syntheticus is a Swiss startup on the forefront of synthetic data generation. The main goal of the project is to benchmark Syntheticus's proprietary algorithm and then compare it with other competing synthetic data providers. We used, obviously, Syntheticus, YData, and SDV. So what are the challenges with synthetic data? Firstly, fidelity. Is the synthetic data representative of the real data? Secondly, scalability. How to increase faithfully and privately the amount of generated data? And lastly, privacy. Is the synthetic data prone to data leaks? The data we use to benchmark is publicly available financial data. It is an 8-table dataset with various connections. The tables have a mixture of numerical and categorical columns, which is a really big challenge for data synthesis. Due to the time constraints of the project, the transaction table was trimmed down to 1,000 transactions from 1,000,000, while still respecting the referential integrity.
Our approach involves starting with 8 tables from our dataset and designing various experiments with different table combinations of increasing data size. These combinations were processed by the Syntheticus algorithm and its competitors YData and SDV to produce synthetic data of comparable sizes. We finally evaluated the synthetic data's fidelity and scalability against real data using the SD metrics library and also assessed privacy levels with the anonymizer tool. Here are the results. We relied on 4 metrics to assess fidelity. The first, column shapes, examines the similarity of value distributions between real and synthetic columns. The second, column pair trends, measures correlations between every column pair within tables, while inter-table trends does the same but across parent and child tables. The last metric, cardinality, evaluates the preservation of table relationships according to the original data. Notably, SDV in red underperforms, while data in orange is best for reproducing distributions and correlations, but struggles with cardinality. Syntheticus in green closely trails YData in distributions and correlations, but excels for cardinality. Overall, Syntheticus emerges as the best model for fidelity. Looking at the average score per table present in the benchmark set, we found that the performance of SDV drops for loans and permanent orders due to the presence of numerous categories in these tables. In addition, YData struggles with the table of transactions due to large numerical values. However, Syntheticus in green is the most robust model as it performs best for all tables of different sizes and data types. So in terms of scalability, we report here the average fidelity score per number of tables included in the benchmark set. In red, SDV's performance obviously decreases with the number of tables, while data in orange shows quite a similar decreasing trend. On the other hand, Syntheticus' score remains high and uniform upon increasing the number of tables, making it the most promising algorithm for scalability.
Okay, so for privacy metrics, we have 3 different evaluators to measure the risks of data leaks. The first is singling out, meaning attributes that are unique in the synthetic data might also be unique in the real original data. Second comes linkability, meaning with 2 or more sets of known attributes, whether the synthetic data is prone to expose that they belong to the same real entity. The last one is inference. Here we assume the attacker already knows parts of the original attributes and whether the synthetic data enables the attacker to make correct inferences about other attributes. So here are the results. We passed through all 7 tables generated by the 3 algorithms separately to the privacy evaluators and took the average scoring. We observed YData's performance tends to fluctuate, while Syntheticus and SDV are both nice and stable. As a benchmarking conclusion, we'd say Syntheticus is the relatively balanced algorithm for privacy. In summary, we can see Syntheticus is a more robust model across fidelity, scalability, and privacy compared to the other two. Worth noting that as the main three metrics represent the functionality and integrity of the synthetic data and hence should be taken with equal importance. Here we are amazed that Syntheticus does a good job achieving an all-round scoring. As next steps, we suggest expanding the volume of data and perspective of measurement so as to test out constraints of the synthesis algorithms, including evaluating utility of the synthesis algorithms for possible downstream use cases of the synthetic data, as well as introducing differential privacy into the synthesis to look into the impact. Last but not least, we'd like to thank Syntheticus team for their tremendous support and Constructor team for their patient guidance all along. So feel free to reach out to us data scientists, and we'd love to hear if you have any questions. Thank you for your time.